Morning to all of you. Welcome you guys. Welcome you all. So, how you are doing, everybody? I think we are live. Yeah, first of all, do comment करके बोलिए. So, is my audio videos clear to everybody? I think we are live. Right. First of all, you can see now here. So, this Unacademy. So, great news to all the aspirants who are seriously preparing for 2027 के लिए. Now, the Unacademy subscription that is just 8,499 rupees only. And you can see now 1 million students has trusted us. 1 million students trusted us, so they achieved their dream goals. Now it's time for you. You trust us, you will definitely achieve your dream goals. So here you can find the live classes from the top educators, and you can get the complete syllabus coverage and the test series PYQs के साथ you will get the 3 months का आपका revision भी मिलेगा. So it's a limited period offer. Do join immediately and to have the great learning experience. And you can use the code of BV Reddy and to avail this great opportunity. Do join immediately and to have the great learning experience from the top educators. Okay. Now the last live batch is started. You can see now here the last live batch of Unacademy. You can see it started. And so these are the three educators, top three educators of EC and electrical. You can find. You do enroll for it immediately. So the last live batch is started from the 24th July से शुरू हो गया. You can see now we started the control systems and the network analysis is started. You can find the top educators team एक साथ आपको मिलेगा. Right. The last live batch we are starting for this is the batch for 2028 के लिए नया batch. So, and another greatest news is now, and the test series available. Totally, how many tests you can see this? 73 tests. Totally 73 tests you can find. And so that is just 1499 rupees only. And Unacademy 2026 का rankers, ESC 2025 का rankers you can find. And these are the we offer the 2 subscription plus वाला iconic. अगर आपको गाइडेंस के साथ गाइडेंस भी चाहिए तो you will go for the iconic subscription. Physical notes and guidance चाहिए तो iconic. वरना this plus is fine. Mentorship program is there. Let's start your serious preparation to achieve dream goals. चलिए आज का सेशन हम शुरू करेगा. Now, so this is assignment 2. So we complete assignment 1. We have finished it now. Now it's for assignment 2. So chalo, let's see one by one problems. Take these problems and try to solve it. मेरे साथ solve करो सभी. Now calculate the equivalent resistance RAB at terminals A and B. Equivalent resistance they ask to find. Yeah, you can tell me now here. Yes, so if any repeated problem will come, do inform, we'll move to the next problem. ठीक है? अगर कोई repeat हो गया तो tell me now. Some cases may be repeat होगा, so let me know if anything is repeated. Yes, now you can see now first problem. Now, so we have a three resistors, and how these three are now, these three are in parallel, right? We can find the equivalent of this. We'll find the equivalent of this now. So let's find the equivalent of it. You tell me now here. This is 20 parallel to what we can say now 30, and that is parallel to 60. So you can tell me now here, then it is. So 60, which will be given as 60 into 2. We are multiplying with the 2, divide with the 2. Now we are multiplying with the 4, divide with the 4, and this multiply with the a. So or we can directly will do 2 से हो जाएगा ना, so 1 से भी होगा, isn't it? Now this is 30, so we are multiplying this 1, divide with 1, multiply with the 2, divide with the 2, multiply with 3, and divide with 3. So this means which will come to be a 60 na? 60 by 6, which will be equal to 10. 10, 10 series will becomes as how much now? 20. And then how much it will becomes, you see this thing. Now from that, how much this value now? This is RAB, which will come to be a 80 parallel to 10. So we can write as what, tell me now, this is 80 by, so 80 parallel to 20, so not 10. So this is 80 parallel to 20. So we'll multiply with 4, divide with 4. So that means 80 by 5, which will be equal to how much now? 16. Okay. Got it all of you, tell me? Next. Calculate the equivalent resistance RAB. Yes. Okay, this problem repeated, I think so. This problem is repeated. Yeah, now take this problem. I think this is not repeated now here onwards. Now you tell me this problem. So you ask him to find the equivalent resistance between A to D. Now you tell me now first RAD. RAD. If you observe carefully, how you need to solve this type of problem, you see. So this is A and this is B, and here we have C and this is D. Look at now here. How you need to find now. Right. Right here this is 2 ohms and this is 4, and here this is also 4, this is also 4. Yeah, tell me now here in this case what we can do. Now, first I need to find what, tell me now, RAD. A to D we need to get now here. So the remaining we should remove now. Remaining tails will remove simply like we did yesterday's. Now, tell me now this connections here. Now I don't want B not required, remove here. C also not required, remove this thing here. And you see the flow of current now here. How the current will flows, you can have a look at now here. The current which is started at A, this current is I. And so here some current will go here, this current which will be a I1 and this current is I2. Now this I1 current will go like this, will go like this, after that will go like this, isn't it? So here this current is I1. Here this current is also I1. Now if you observe carefully, the current passing through the 2 ohm and this 4 and this 4 is same only now. If the current is same, how the connection we can say now series I can write. So we can say now this RAD, which is equal to what we can say now, 2 plus 4 plus 4. Yes, and parallel to what you tell me now, 4. Understood this point? Tell me. Right. So any Lattice circuit problem we can do like this. Now you tell me now what is this RAD now? So this value 10, 10 parallel to 4. So how much this value, tell me now, RAD, which will be equal to 40 by 14. So we can say this as a 20 by 7 ohms. Got it? Next, we need to find RAB. Let's find RAB now. A to B. RAB. Tell me now, RAB here also we need the A to B required. So those tails only will keep remaining tails, we can remove it now, these extra connections. D not required, C not required. Removed now. Now see the flow of current now. The current which is I, the same current has to reach to the point B now. Now you tell me now the current which will go here. This current is I1 and this current is I2. Now tell me now this current I1 will go like this, and this current is I1. Okay. Now this current will go like this and like this. This current is I2. So from this you can tell me now RAB, which is equal to, so the same current is passing means series. 2 plus 4 parallel to what we can say now, this is 4 plus 4. And simplify and get it now here. So that is RAB, which is equal to 6 parallel to 8. So that means how much now here? 6 into 8 by 6 plus 8, which will be equal to 614. Now will be a, so if we cancel with the 2, say, that is 2 3s and 2 7s. That is finally what it is RAB now here. This is 24 by 7 ohms. Okay. Next. What else we need to find? You can see now. And we need to find where now here. A to C we need to get now here. Let's get the A to C now. That is RAC. Now tell me now A to C we need now here. So B not required, D not required. Removed now. B not required, D not required. Yes, very good morning. So tell me the answer for it now. BD removed. So tell me the direct flow current now here. The current which is started at here I. Now you can see now here this some current will go here. This current we can say this as I1. And so this current which is I2. Now you see this thing, this I2 current will come like this, will go like this, will go like this, will go like this, and will go like this. Isn't it? Now this, what we can say now here, that is RAC, which will be equal to. So this is same current means series 4 plus 4 plus 4, and this whole combination which is in series with 2. Tell me now here RAC, which will be equal to what? Tell me now 12. 12 parallel to 2, which will be equal to 12 into 2 by 12 plus 2, 14. So 2 sevens, which will come to be what? Tell me now 12 by 7. Next, what else we need to get now here? BC we need to get now here. RBC. So you tell me now RB to C now. BC. Now B to C we need the terminals now here. A not required, remove it now here. D also not required, remove this thing. Now see the direction of flow of current now. Current which is started here. This current is I and this current is I. Tell me now here this current which will be I1 will go and this current which is I2 will go. Now this I1 current will go like this, like this, like this will happen. So you can tell me now RBC and which will be equal to what? Tell me now here 4 plus 2 and this is parallel to what? Tell me now 2, which will be equal to 10 parallel to 2, which is 10 into 2 by, yes, 10 plus 2, which will be at 12. So this is 6, this is 3, and this is 5, which will come to be what? Tell me now 5 by 3 ohms. Okay. Next one. Now you can tell me now this. So first of all, what we can do here, these two are in series 8. Now if I redraw the circuit, Now this is 8 ohms, and here which we have it 2, and this is 1. This is A and B. This value, how much now? This is 0.8, and this is 6 ohms. Right, like this. And here we have one more 6 is there now. So you need to observe the things now. How should be the connections? You tell me now what we can do. How should be the connections here? Carefully you see this thing here. Now look at now here. If we call this point is C and this point is D, and this whole thing, this point we can say E only in a same point now. Yes. So you need to observe here. This 6 ohm resistance between way to way now here. This C to E, and this 6 also between C to E only. So what I can do here, this I will remove this thing here. The 6 that I will be connected here, and this I will be connect here. Understood? Tell me now, this is 6, this also 6 only. Now, from this, what we can write, you tell me now here. These 6, these two are parallel will become 3, and this also will become 3. So now we redraw it now here. Right. So this value how much now? 3. And this value how much now here, which is equal to 3 ohms, and this is 2, and this is 1, this is 0.8. Now simplify now. So now these two are in parallel. How much this value? So this is 3 into 8 by 8 plus 3, that is 11. And thereafter series. So that means we can say now plus 2. So how much this value will come here? This is 24 plus 22 by 11. So this value which is equal to what you tell me now, this is 46 by 11. 46 by 11 and 3 are in parallel. How much this value tell me now? 46 by 11. So how much is better? We'll simplify this thing. How much is 46 by 11 here? So this 4 point something will come now. This is 4.18. So this is 4.18. And then 3. So means what we can say now, 4.18 into 3 by, so this is 7.18. How much this value you can tell me now? 4.18 into 3 by 7.18. So this value come to be this is 1.74. 1.74 plus 1 plus 0.8. Finally, will come it as RAB, which will be equal to, that is 3.54 ohms. Okay. So this is little calculations, but easy only. Next to the next problem. Yes, all these values are given as 2R, 2R, 2R. Here this network has a symmetry. What type of symmetry it has? You can tell me now. It has a perpendicular symmetry. It has a perpendicular symmetry. So perpendicular symmetry now here. So about this line, this network is symmetrical, isn't it? About this is a perpendicular symmetry. So because of this, and there is no flow of current here now, so this element will become a dead element. The circuit which will becomes as like this. Okay. Now here this is A and this is B. Okay. So here this resistance which is given as 2R given, and this is given as 2R. Here we have a 2R. Here is there, 2R is there, and here also we have a 2R. Okay. Now, so this element is dead element. There is no flow of current. Now we have removed that element. Right. Now you can tell me now. So this is this 2R, this 2R, these two are in series will become 4R. And this also 4R. Again parallel will become 2R. 2R, 2R. Again in series now, sorry, parallel. So that's why RAB, which will come to be a what? Tell me now. R. Check it, everybody. RAB will become as simply R only. Right. Next one. Tell me now this one. In this case also the network has symmetrical. Here you see what type of symmetry, you tell me now. Perpendicular symmetry. It has symmetry. What type of symmetry? Perpendicular symmetry. This network has a perpendicular symmetry. Fine. If the network has a perpendicular symmetry, now you can tell me what we can see now here. So the current passing the overlapping branches is same. Okay. So that's why. So what happens? You see this thing here. If we call and this current which is coming I, and this current is I. Now let's see now carefully now here. Here this current, if I call this as I1, this current is I2. When I fold it now here, this branch will overlap with this branch, right? So then current must be a same only. This current must be also I1 only. And then this current is what you tell me now, I2. Now, so this is now, so we can see now this current which will be equal to I2. So then after reaching here, the current, some current will go here. If I call this is I3, and this current is I4, and this current is I5. Now you can see now this I4 current Sida like this will go like this. This current is how much now? I4. And then this current is I5. This current is also I5. And this current you can see now I3. So that's why this current is also I3. Okay. Now if we observe carefully this current which is I1, so coming like this, like this, like this, and straight away we going like this. This I3 current going like this, isn't it? Now if we observe this thing here, how I can redraw this circuit, you need to see here, this part of circuit. Yes. Yes, like this he is there. So, but here we need to do little adjustment. We'll made it now. This is A and B. Here you see this thing here, right? And here we have the resistance here. Here we have the resistance. Here we have the resistance. Resistance are there now here. Okay. Now look at now carefully what you observe here. Now this I1 current is coming simply going like this I1. This I3 current simply going like this. Now this I1 current is coming and it is going like this I1. And this is I3 current, and this is simply going like this I3 current, right? This I3 current which is not coming here, I1 current is also not going here. So what I'm doing now here, so I'm doing a little adjustment now here. So here this, even though we have the connection, but there is no use of this connection now, you see. There is no effect of this connection. Yes, sir. Now tell me now. Even though there is a connection, physical connection is there, but so there is no effect of that connection you observe here. There is no flow of current in the particular branch, isn't it? Tell me. Understood what I am saying? So that's why we have removed the connections now here. So this resistance, which is a 3R, this is also 3R, this is also 3R. So 3R, 3R series, 6R, 6R and 3R are parallel. So this means how much this value will come here? That is 6R parallel to 3R. So will come to be what, tell me now, that is 6R by 3, and which will come to be what, tell me now, 2R, right? Now again, so then this value 3R, 3R, 6R parallel now, that is 2R parallel to what, tell me now here, 6R will come to be a multiply with 3, divide with 3 now, will come it as 6R by 4. That means what, tell me now, 3R by 2. Okay. Now this will be 3R, 3R. Here we have 3R. This also 3R will becomes what? Tell me now. 6R. Then finally, if we redraw this part of a circuit, then how it will come? Tell me now. So this is 6R, A and B, right? And here we have a 3R, and here we have a 3R by 2. Next, again, this is 3R. Check it, all of you. This is 3R by 2. Okay. Now you can tell me now here these connections now here. So this 3R series 6R, 6R plus what I do now 3R by 2, which will be a 12 plus 3, 15. So that is 15R by 2. Now we can say this as 15R by 2 parallel with what I do now 6R. So we can write it as what you tell me now here, how much? So that is RAB, and which will be equal to, so that is 15R by 2 into 6R by, what tell me now here, 15R by 2 plus 6R. Now simplify and get it now here. So that is 15 into 6 into this is R by 15 plus 12. Come to be a 15 into 6 into R by this value 27. 27. So this means 3 nines. Now 3 twos, 3 threes, and 3 fives. This value will come to be how much now? So this is 10R. 10R by 3. Okay. Got it, all of you? Tell me now. Sure. Next. Tell me the next problem. They asking a convert into a delta to star. Tell me the conversion from delta to star. So delta to star. So this is R1. So delta to star conversion we know now. R1 is here. So that means here we got this is the resistance. It is R1. Tell me the R1. R1 कहाँ से आया? RB RC से आया. So that will be given as what I can say now, RB into RC by, remember the trick now, RB plus RC plus RA. So tell me now how much will come this R1 value, B and C. RB value 10. So this is 10 into 10 by, so sum is 40. So this value how much now? 2.5 ohms. Next we have R2. R2 means here na. This is R2. So that is R2, which could be given as. Now this is R2, which is given as what we can say. Tell me now. R2 means RA/RC. So tell me now RA/RC. That is given as RA. That is RC. That is RA plus RB plus RC, and which will be equal to RA/RC. How much is RA value? RC value, RA, which we have at 20, RC value 10 by 40. So this value, so 2's, which will be equal to 5 ohms. Next, what about this as R3 now here? Here is R3 now. Here is R3 will come. So tell me now how much is R3 value? R3, RA, RB. So that is RA, RB by what? Tell me now. RA plus RB plus RC, which will be equal to RA. So this is 20 into 10 by 40. So this is also equal to 5 only. So option A. Next, if each branch of a delta circuit has an impedance is given as a √3Z, they are asking the corresponding star network they are talking here. So tell me now, delta will have a impedance. They are saying each one having the impedance is √3 into Z. This is √3Z, and this is √3Z, and this is √3Z. They are talking about what? You tell me now here. So Y network value they are asking. So if I call this is the value, if I call this is the Z1, yeah, you tell me now Z1 equal to, which will be equal to √3Z into √3Z by what we can say sum of all na. So this is √3Z plus √3Z plus √3Z. Okay. Now, so this is Z1 value will come to be a, so this is √3Z into √3Z by, we have what? Tell me now. This is √3Z into 3. So tell me now here, this √3Z will get cancelled. So how much the Z1 value? Tell me now here, this is Z by √3. Now, the equivalent resistance of the network shown in the figure they are asking. Right? Tell me the equivalent resistance now. So R equivalent we need to find. So let's find out now here. If I call this point is X and this point is Y, X2Y we need to find. And locate this point now. This is now X. And we are calling this point is A. And this point is B. This point is A means this also D also A only in a short path, and this is B now. Next we have B, and next we have what? Tell me now. This is Y. Okay. Next, now let's redraw the circuit now. X2A, how much we have the resistance now? X2A, which we have it 2. Next, A to B, that is 25. A to B, which we have the resistance. How much now? This is 25. Next, B to A. B to A, how much this value? Yes, B to A means A to B only now. So how much this value? 50. Right, so this value which is equal to 50. Next, A to B. So this is also 50 only now. A to B. This is also 50. Next, B to Y. B to Y, which will be equal to how much? You tell me now. This is 8. Now tell me now. Simplify this thing here. Now these three are in parallel. These three are in parallel. How much is value? 25. 25 by 2, that is 12.5. So that's why we have RXY, which will come to be a what? Tell me now. 2 plus, this is 12.5 plus 8, which will come to be how much now? 22.5. Next one. Resistors of 10 ohm each are connected as shown in the figure. The effective resistance they ask to find from A to G. Right. So first you can see now. Right. So first we have these two. If I call this is R equal 10. This is a parallel now. So it is R by 2. Now series. So it will become 3R by 2. 3R by 2 parallel to what you tell me now? R. So this will come to be what tell me now? 3R by 5. Okay. 3R by 5 and this resistance series na here. So 3R by 5 plus R, which will come to be what tell me now? 8R by 5. That means R value they given na A to G, which is equal to 8R by 5. That is equal to 8 by 5 into R value how much now? 10. So which will be equal to 5 2 which will be equal to 16 ohms. Now see this thing here. Which arrangement of four identical resistors should be used to draw the maximum energy from a cell of voltage V? Maximum energy means maximum power is also maximum. Energy maximum means power is also maximum. So now what should be the condition now here? Now in this case, energy maximum is power also maximum. So here this is connected to some supply they connected. So that means voltage constant and the power equal to what tell me now? V square by R. That means how this power proportional to the resistance you tell me now 1 by R na. That means if the high resistance means power is low. So based upon that we can able to get it. So let's find the equivalent resistance in each case. Equivalent resistance each case. Yes, now here this R by 2, R by 2. So that means here it is a R equivalent, which will be equal to R. Here, R equivalent, which will be equal to R by 4. Here, R equivalent is how much now, which will be equal to 4R. Here, this is R by 3. R equivalent is what tell me now? R by 3 plus R. So that's why here we can say R equivalent is what tell me now? 4R by 3. Okay. Now, which case we have a high resistance? You tell me now. So in this case, so here we have, in this case, we have a low resistance means high power. So second option. Next one. Four resistors are connected as shown in the figure. The effective resistance between A and B is, right. So this is A and this is A. Now we can say this is now C. So now we can say now this point which will be equal to A. This point is A. And we can say now this point which will be a C and this point which will be a B. Now A to C we have a resistance which will be equal to 4. Next, A to C, we have the another resistance, and that is which is equal to 4. Next, C to B, we have a resistance 1.6. C to B, this is 1.6. Next, A to B, we have one resistance. A to B, we have one resistance, and which is equal to 4. Right. Now you can see now here these two are in parallel. So which will come to be a what element now? 2. 2 and 1.6. So this is series 3.6. Now what will be the RAB now? Tell me now. These two parallel. So it will come to be a. So this is 3.6 parallel to 4. How much will come here? 3.6 into 4. This is 6 now. Sorry. This value 6. Okay. This is 6, not 4. Okay. So how much this value? 6 into 4 by 6 plus 4, 2.4. 2.4, this is, which will get it as a 4. Now 4 parallel to 4, and which will come to be a 2. Consider the star network shown in figure. Between the terminals, the resistance between E and B with C open given as a 6, and between B and C with A open given as 11, and between C and A with B open is given as a 9. Okay, they given the resistance. The resistance between what to what given, you see the resistance which is RAB between A to B, which is given as what, tell me now, and which will be equal to RA plus RB. How much this value? Tell me, they given as a 6. So let us say this is one equation. The resistance between B to C, that means what I mean, A is open, B to C means that is RB plus RC. How much this value given is a 11. And the resistance between C to A, which will be given as that is RC plus RA, and which will be equal to how much? RC plus RA. How much this value left? That is 9 given. So let us say this is the third equation. Now I am adding all the three equations. If I add, will come it as what terminal? 2 into RA plus that is RB plus RC, and which will be equal to 16. 16 will come now. No, sorry, 26 will come. This value, how much now? 20, 26. That means we have RA plus RB plus RC, which will be equal to 13. Now we are calling this as a fourth equation. Fourth equation. Now you tell me now, from if I subtract now 4 minus 1, if I do, what happens? Will come this RC value will come. How much this value? 13 minus 6, which will be equal to 7. Okay. Next, 4 minus 2, then it will come to be what, tell me now? RA, and which will come to be a 2. Next, 4 minus 3, this will come to be a what, tell me now? RB. RB, which is equal to how much, you tell me now? Correct only. Yes, RB. So this is which will be a 4. Okay. RA value, how much you tell me now? So this is now here. RA will come. Yes. So here RA value 2, RB 4, this is 6. This is 7. Option B. Check it, everybody. All of you do like the session. Do like the session and share to your friends. All of you. All resistors are 5 ohms. Then they ask him to find the equivalent resistance. Yes, so here tell me now, first of all, these two are in series. Will come to be a 2R, 2R and R parallel. That is 2R by 3. So this is 2R by 3 plus series. So this value will come it as 5R by 3. And parallel with the R na, so it will come to be a what tell me now, 5R by 8. 5R by 8 plus R. So that is R equivalent, which will be equal to 5R by 8 plus R. So will come to be a 5 plus 8. How much is value? So 13. So this is 13R by 8. Check करो सही कि नहीं. Now these two, if I say R, now this value how much now? 2R. Next 2R and this one will becomes as what I mean 2R by 3 na parallel plus R if I do will come it as 5R. So this will be how much now? 5R by 3. 5R by 3 parallel to R. So that is 5R by 8. Yes. So this means how much now? 13 by 8 into 5. So that is 65 by 8. Right. Next one. Tell me this one. Yeah, here these two are in series. How much is value? So here 240. 240 and 60 parallel. So this is 240 parallel to 60 na. So if we multiply to 4 na, so this value will come to be a 240 by 5. Now this value 240 by 5 means how much is value? 5. 4, 5, 8. This is 48. 48 and 25 series. So that means RAB, which will come to be a 48 plus 25. Isn't it? Tell me. Hmm? All of you do like the session, share to friends. How much now? This is 73 or 72? 70, uh, 6, 73, yes. Next one. And you can see this thing here, how much will come here. Now here, this, how much you tell me now this is? 160. This is 160. And this 160 and this 160 parallel will come to be how much now? 80. And 80, so we have this is, here we have this is 28 plus 80 plus 52. How much is value? This is again 160. So this is again 160. 160 and this 160 will become 80. 80 plus 20. So that means R equivalent will come it as what? Tell me now. 100. Okay. Next. And you tell me now this thing. Okay, first these two parallel and these two also parallel. So we'll find the equivalent of these two first. So this is 12 by 3, which will be equal to 4. Yes, so this value is a 4, and this is how much now? 20 parallel to 80. So this means which is equal to 80 by 5, which is equal to 16. So this value is 16. Okay, 16 plus 6 are series, 20. 20 and 60 parallel. 20 parallel to 60. So will come to be a what, tell me now? That is 60 by 5, which will be a 12. Okay, 12 only now? Yes, 12 and 15 parallel. So this is 12 into 15 by 12 plus 15. So this is 27. Now will come to be a, so 3. So 3 fours, 3 nines, 3 threes, 3 fives, which will be a 20 by 3. Okay. 20 by 3 means 6.666. Like this will come now. 6.66 plus 2.5. So that means R equivalent is what I know, 6.66 plus 2.5. So will come 6.66 plus 2.5. This value 9.16. Isn't it? Check it all of you. कोई कैलकुलेशन गलत है तो बोलिए. Next one. Convert the circuit Y to delta. Y to delta. That means star to delta. We need to do it now. Here in this case, first case, all the values are same only. So will come the same will come. If I call this resistance, which will be equal to something R. So you can tell me now what it is R1 will come. So this is 10 plus 10 plus what, tell me now, 10 into 10 by 10. Yeah, which will come to be a what, tell me now, which is equal to 30. Remaining also will come same only now, tell me. Remaining also will come same, right? Now same thing we'll do here now. Here this is R1. So you can tell me now this is R1 means which will be a, so 20 plus 50 plus 20 into 50 by, so 20 into 50 by 30. So this value, so that is R1 value will come it as 70 plus 100 by 3, which will be equal to 21. So this is 310, isn't it? 310 by 3. Next, by joining here, will come this as R2. Yes, tell me for this R2 now. So this is 30 plus 50 plus what, tell me now, 30 into 50 by 20. So this is 25. So this is R2 value how much now? 80 plus this is 75. So this is 155 now. Next here will come the R3 if I say. This is R3. Tell me for R3 now. Tell me for R3 now. So this is 30 into, sorry. So this is 30 plus 20 plus 30 into 20 by 50. So this is 5, 6. Now this R3 value which is equal to 50 plus, so 12. So this is 62, like this. All of you do like the session. Next one. Now transform into delta to star. Previously we have seen Y to delta. Now delta to star will do. Yes, so you can tell me now here also this all the values are same. That's why will come it as same will come. Let us call this is my R1. So you can tell me now what will be the R1 now. This is 12 into 12 by 12 plus 12 plus 12, which will be equal to 12 into 12 by this is 12 into 3. So which will be equal to 4. Yes, remaining also same only. Why? Because the values are same only now. This R2 is also equal to 4 and R3 is also equal to 4. Now let's get now here. But here the values are different now, so we'll get different values will come. Yes, so this is R1, R2 and this is R3. Yeah, you can tell me now R1 which will be equal to, so 30 into 10 by, so sum of all, so 100. So which will come to be a 3. This is R2 is what I know 60 into 10 by 100, which will be equal to 6. Next, R3 is what tell me now 30 into 60 by 100 sum, which will be equal to 18. Right. Got it now, all of you? Yes. Now, fine, that's it. The same manner will continue. Next class will continue. And do follow the classes regularly so that we discuss the maximum problems I will discuss for you. So now with this resistance part completed, next we'll do the capacitance analysis. We'll do next class, and thereafter KVL, KCL, and all the voltage division problems, and we'll do the nodal analysis, mesh analysis problems. We'll do. Okay. Okay then. See you. Bye bye.